All right, so we left off here at question 7.28, and we're going to take a look at each one of these problems. So if we take a look at the first one, we have a secondary alkyl halide, put a stereocenter in it, and we're using sodium chloride. So if we look at sodium chloride, that is sodium plus and Cl minus. So if we look at chloride, chloride is a strong nucleophile, but a weak base. And then we have a secondary alkyl halide. So if we go back to the table, which was all the way back here, we have the chloride ion, we have a secondary alkyl halide. And so the only thing that's going to happen is SN2. Is everybody with me on that? Give me a thumbs up if you see the only thing that's going to happen is an SN2. Good. And we're going to get inversion of configuration, of course. So let's go back to the problem here. And so that stereocenter is going to invert. So the only thing that's going to happen here is that the chloride ion is going to do a nucleophilic attack onto the bromide, and we're going to lose that bromide, and we end up with our product, which is going to be this guy here, and there's our chlorine, and we're done. Okay, in the next one, we have a tertiary alkyl halide. So this is a tertiary substrate. We have T-butoxide. So if T-butoxide is a base, right? If we draw the structure of T-butoxide, it looks like this. So let me ask you first, would T-butoxide be a strong nucleophile or a weak nucleophile? And this is a tricky question, I'll admit it. Because if you look at the negative charge, you'd think, well, it's a strong nucleophile because methoxide and ethoxide are strong nucleophiles, but it's actually a really crappy nucleophile, right? Because it's too sterically hindered, okay? So it makes a much better base. So we would just write here, this is a hindered base. Hindered base. So this is going to fall under the umbrella of strong base, but weak nucleophile, okay? So we'll put here strong base and weak nucleophile. And if you're thinking, well, wasn't that like sodium hydride, DBU, DBN? Yes, T-butoxide would fall into the same category. And so the only thing it's going to do is E2. It's the only kind of chemistry it can do. And now we have two types of beta protons here, right? If this is our alpha carbon here, we have the red protons on the methyl groups, but then we also have this as a beta proton here. So if we were to pluck off the proton in red, we would end up with this product, like this. Put it like that. Still not good. Like that. And then if we pulled off the proton in blue, we would end up with something that looks like this. Okay? So could anybody tell me which one of these is going to be the major product? Would it be the one in red or the one in blue? If the only thing we're getting is E2. It's going to be the one in blue, right? Because it's the more substituted product. So this would be our major product, and this would be our minor product. So again, this is SN2, this is E2. Do the last one. So we have DBN, and again, I'll go over the structure of DBN later, but DBN we saw is a strong base and a weak nucleophile, and we have a tertiary alkyl halide. And so the only thing that can happen here would be E2, because you can't get any kind of substitution with something that's a poor nucleophile. And so the only thing we're going to get in this case would be E2. And how many types of beta protons are there in this molecule? There's only one kind, right? Because these two methyl groups are identical, right? Because there's free rotation around this bond. The two methyl groups are identical. And so there's only one kind of beta proton, this one here. There's no beta protons here. And so the only product we're going to get in this case will be this. We have our aromatic ring, and then we have a double bond like this. And so again, the only product that we get here is an E2 product. That is it. So that finishes question 7.28. And so again, you really need to familiarize yourself with the two tables that I showed you, the table that identifies the strength of base and nucleophile, And then also this table here that kind of helps you make a decision as to what kind of mechanism is going to predominate.